So part 2 of 2.1.4 force vectors, we're starting number 9. It's a free body diagram and solving the components for the picture hung by a nail and some wire. But before we get started on doing that free body diagram, we're going to look and notice that the two vectors, A and B, are very similar to what we just did in problems 1 through 8. So questions 1 through 4, you're really looking at vector A of the nail. So notice 30 degrees, A is 5 newtons. Okay, keep that in mind. We have B 5 newtons, 30 degrees left, down and left, and there you go. So what we're doing is putting them together, and what we want to do is get a free body diagram of the combination of vectors A and B. So that combination just simply looks like this. Your vector coming down for both A and B, so we'll draw that separately. We also have the x component of vector A, and we have the x component of vector B. So I'm going to go back to my find point, and I'm going to say this is A in the y direction, B in the y direction, and down below we have A in the x direction, and B in the x direction. So your free body diagram, basically that's it. We'll put numbers to it here in just a minute. But that is your free body diagram. In component form, we have our y for A and B overlapping, and we have the x for A is pointing to the right, and the x for B is pointing to the left. When it says solve the component vectors, well, we already did that. So what I'd like to do is, instead of redoing all of our math from 1 through 8, I'm just going to summarize them in a quick table. So all I got to do is come up to question 4, and it was 2.5 newtons positive to the x of the vector A. The y was negative, so we got a negative 4.3 newton y component. B in the x direction was negative, same magnitude as A in the x direction. In our y, again, negative, it's pointing down, so we get negative 4.3. So what I would do to make our free body diagram complete is I would then label these as all the magnitudes. And number 9 is done. Question 10 is calculate the xy components of the resultant by summing them together. So what we're saying is we're going to sum the forces in the x direction. The only two x direction forces are force A sub x and B sub x. So our summation of forces in the x direction is positive 2.5 minus 2.5, or plus the opposite 2.5. So the sum of forces in the x direction is 0. Our resultant is 0. Not the same case for our y direction. Force A, or component A in the y direction, was negative 4.3 newtons, but so was the B component in the y direction. Was also negative. So when you look at the grand total of forces, the sum of the forces in the y is a combined negative 8.3 newtons. So I would again box that answer and that, just so that I am clear as a teacher when I look at these. I want to be able to quickly look and find what is your final answer. And if it's not right, then I can start looking at your work. But that's 9 and 10, calculate x and y components. Part 3, I'll do 11 through 11 through 15. So I'm going to stop this video here. It's just questions 9 and 10.